Hi, I'm Brendan from Cobot team, and today I'd like to speak with you about path planning with the Dobot CR5. A lot of people who have this robot use drag to teach method to teach the arm a trajectory. That's useful, but sometimes you need more accuracy in a path that you want the robot to take. So I'm going to explain how you would go about creating a path from a mathematical formula, in this case a parabola of xy coordinates. Before I do that, I'm going to demonstrate the drag to teach method of path planning. So I'm going to go over here. I'm going to hold the record button on the arm, move it around, save it, and I'm going to hit the playback button. And it'll redo my lovely path. Okay, so what happens when we do that? We end up with a list of joint positions that are sampled every 50 milliseconds. So when we go into the GUI, we have it here. So we can refresh this. It's under button drag track. You can start the playback again. And again, you'll see the robot do the same thing. Sort of simple. So now we know that that is a file somewhere. And that file is actually saved up here. It is a network file. And you'll see all the trajectories I've created. So one of them is button drag track, and that is the one that we just created. Okay, so now what we want to do is take some Python code and regenerate one of these files using a mathematical formula. So the first thing you do is you go into Python and you can look at your, make my face smaller here. You can use the Python SDK, and I don't know if it's easy to see this, but right now I have a couple functions, one of which is creating a parabola. Okay, so there's my parabola, and those are the points, that's the list of points I'm going to feed into my script. So first of all, there's really good functionality to the Dobot SDK, and so one thing we can do is actually just run some moves. So here's a function that gets the coordinates, and then we have the SDK function move joint. And so I'm executing a list of 60 points of a parabola. Problem with this is that it's slow and it stops between points. So I'll run this and you'll see the arm kind of follow a parabola but slowly because it has to get the message each time. So it's going to take a path 60 points long and just do a joint move for every path as it gets sent a new coordinate. And pretty boring and slow. Okay, so now stop that. We're going to look at changing that to a path file that we can then run. So what we do now is we go back to that code. I'm going to comment out the part that has the move arm, which is right here, and we're going to go to take the comment off of this line, and we're using what's called inverse solution. An inverse solution is taking the XYZ pitch, yaw, and roll coordinates and turning it into a joint position. So what we're doing now is creating a list of joint positions from the coordinates that we have created. I have a base location of the arm, and then I have my X and Z coordinates adding to those values and returning a joint position for each one of those. So when I run this, it's going to generate that list, and then I'm going to look at this function, and this is the function that will create my file. So it's going to spit out to this path a file called data0, and that's going to have all the joint positions. So if I go to back to my Dobot studio, once this finishes running, I should see a path or a file in here called data0. I'll refresh this. Make sure you can see. And here's data0. And as I run it, you'll see the movement of the parabola behind me in a much smoother single path. And that is essentially how you do a path plan without moving the arm by hand. Thank you for watching the video. We appreciate your time. If you have any questions, please contact us at cobotteam.com, and we'd be happy to help with any of your collaborative robotics needs. Thank you very much.